everyone, in this video we're going to look at the second example related to the central limit theory and the range of the sample mean. But this one is more also related to the applied, and then hopefully it will give you another perspective of our central mean. Okay, concerned about climate change and the CO2 reduction have initiated the commercial production of a blend of a biodiesel and a petrol diesel. Random sample of 40 blended fuel are tested in the lab to ascertain the bio divided by total carbon ratio. So if the true mean is 0.9 with a standard deviation of 0.005, within what interval will 95% of the sample mean fall? So first of all, as I already called out, this question related to the range of the sample mean. But if I don't tell you, how do you know this is a question related to the range of the sample mean? Because it's in the question. So we're looking for 95% of the sample means will fall. Okay, so that's when you know, hey, this is the question related to the range of the sample mean. Similar as question number 1, and now I require you as you work on these questions, and you need to write down the statistic, the parameters value already given. First, we know the sample size equal to 40, and second, we know the population mean mu equal to 0.9, and the population standard deviation we also given is 0.005. And so and also the last thing is we are looking for 95% sample mean. So after we got those information, and we just open an empty Excel spreadsheet and start to put in those information. Okay, based on the question, we know the sample mean here is a 0.9, right? So that's the mu value. Make sure I'm right. Yeah, 0.9. And the standard deviation is 0.005. And then the sample size here is 40. And then the z-score, as we know, it's a 90. So that is 95%. So based on our PowerPoint, the value given is 1.96, right? 1.96. Now we are able to apply the formula we learned from the from the lecture to solve this problem. So for the lower boundary, it is equal to the mu. We pick the minus sign, and then statistic times sigma divided by SQRT square root of n. So that gives me the lower bound. Okay, and for my upper bound is using the mu. We are using the plus z-score times sigma divided by square root of n. Okay, so if you think I walk here a little bit fast, you can pause the video so you are able to see which cell I selected to get in the number. Again, I did not directly using the number. Instead, I selected the cell where I placed my original numbers, because this really helped me to prevent to have any typos. And I see the student make error before. For instance, in this example, the sigma is 0.005. Some student get down here, somehow they're missing a 0. So then your answer will be totally incorrect, right? So therefore, using this method will prevent you creating errors. Okay. So for this question, the 95% range for my sample mean is between 0.89 to 0.90. Okay, so what kind of distribution this will follow? So if you go back to look at the initial questions, okay, for this sample, we actually did not see if it's a follow normal distribution or not. So if we believe this is a follow normal distribution because we get at least 30, right? So we said if the sample size is larger and equal to 30, we can assume it's follow normal distribution. So what kind of distribution this sample mean actually follow? So given the central limit theory, so this sample mean going to be follow a normal distribution, approximately a normal distribution, with mean equal to 0.9, because that's the same. And then the standard deviation will equal to 0.005 divided by square root of n. So that would be your standard deviation, right? The standard, called the standard error of the mean, is equal to 0.005 divided by the square root of n. So if I'm going to ask what this, besides the confidence interval we already obtained, so if we ask what distribution this sample mean will follow, right? So the sample mean will follow approximately a normal distribution. Again, because the sample size is larger than 30, and regardless what is your original population look like, right? With mean equal 0.9 and standard deviation equal the sigma, remember, divide by square root of 40. Okay, so the reason we have this conclusion because the central limit theory. Okay, so you will work on very similar question in your homework assignment. Hopefully this practice question will help you to understand, hey, what is that question really asked for and how to get an answer, how to apply the formula we learned in the lecture to solve that problem. Okay, good luck with your learning.